section 2.4. We'll try this one again. I seem to have my hand over the microphone for it or something like that. But we'll do a chain rule with 3 functions. And so I could have something like f of x equals sine squared of the square root of x. So as I look at that, what I need to see is this is sine of the square root of x, like that, squared. So as I look outside to inside, I see the squaring function, and then I see the sine function, and then I see the square root of x. And so I can take derivatives of each of these. This first one's just a power function, so 2 to the 1, so I won't put anything up there. This one is, the sine is just a cosine. And now the square root of x is x to the 1/2, and so that would be a power rule also, 1/2 x to the negative 1/2. So those are my derivatives for each of those. So as I look at f prime of x, going from outside to inside, I have my 2 times whatever was on the inside of that. And that happened to be sine square root of x. And then I have the derivative of the sine function, which was the next part there. So that was cosine and of whatever was inside of that. So, square root of x. And then finally, my derivative here of the square root of x, 1/2 x to the negative 1/2. Now, I wouldn't leave it like this. There are a couple things. The 1/2 times the 2, multiply out your constants. Okay, we get 1. And then, power functions, polynomials, that kind of thing, they usually lead sines and cosines when we write them. And so I would write x to the negative 1/2, sine square root of x, cosine square root of x. And now then, that's fine, that looks great. You could, if you wanted, since this is a negative exponent, put that in the bottom and change it back to a square root. And so we have sine square root of x, cosine square root of x, all divided by the square root of x. So you could do that. Either of these is fine. They look fine. Alright, so that is a chain rule with 3 functions, or 2 compositions of those 3 functions. Okay, so hopefully this recording did a bit better.